Hello again. As a computer technician, it is important to understand how numbers are represented in a computer. We live in an analog world of quantities that can be measured and converted to numbers, like force, temperature, pressure, brightness, and many others. Anything that can be converted to a voltage can be measured and turned into a number by a computer. Data can be almost anything. It can be numbers, text, sound, and pictures. All of the tiny dots called pixels that make up this picture are stored in the computer as numbers. This entire show is represented by a series of numbers. Computer data and functions are expressed in a variety of ways. They can be expressed as voltage levels, numeric systems such as binary, hexadecimal, and symbolic codes such as ASCII. Although computer data and commands can be expressed in many different forms and still have the same meaning, the form selected should be the one that is easiest to grasp for the given material. For example, it is much easier to express numbers stored in memory as hexadecimal values rather than binary values. Although the number could be expressed in either value, the computer technician must be very familiar with each of these forms of data expression. The binary number system consists entirely of ones and zeros. It is the perfect numbering system to represent digital electronic systems. Just as digital devices have only two states, on and off, the binary system utilizes only two numbers, 0 and 1. This chart shows how 4 zeros and ones can be used to express different values from 0 to 15. Just like this lamp, binary can be compared to a switch. If the switch is closed, the lamp will be on. This state is represented by a 1. When the switch is in the off position, the lamp is dark. This state is represented by a 0. This may seem like a system too simple to represent data in a computer, but let's compare it to the Morse code system. The Morse code system consists of only two tones, a short beep and a long beep. These sounds are referred to as dot and dash respectively. The dots sound like this. The longer dashes sound like this. The Morse code resembles a binary system. It has two conditions. The dots and dashes can be combined in sequences that represent the alphabet as well as numerals 0 through 9. The Morse code system has been used to transmit information all over the world, such as this ham radio operator is doing. Graphics are transmitted in a similar fashion using facsimile. The light and dark areas are represented by the presence or absence of a transmitted voltage. Again, this is a form similar to digital electronics. The original fax system used drums. One drum is a transmitter and the other a receiver. Instead of an analog signal, today's fax machines send the images as binary data over a modem similar to a computer modem. As you can see, the two-state condition of digital electronics can be much more powerful than it first appears. The ones and zeros of the binary system are used to represent the high and low voltage signals that travel throughout the computer system. They also represent data stored on disks or in memory chips. Let's take a closer look at the hexadecimal number codes. The hexadecimal code is based on the number base 16, similar to how the binary code is based on the number base 2. The hexadecimal number system uses 16 characters. The hexadecimal system uses numerals 0 through 9 from the decimal number system and 6 additional characters from the alphabet, A through F. This combination of number and letter character forms the hexadecimal number system. Binary numbers are too long and awkward to be used to express computer values such as memory locations. Thus, hexadecimal numbers are used instead. The hexadecimal code uses less space. The hexadecimal system best matches the hardware system of most computers. As you will learn, data lines in a computer are 8, 16, 32, or 64 lines wide. They use increments of 8 and 16 which work beautifully with a hexadecimal system. In addition, the number values you will encounter that are used to express memory sizes, such as 256, 512, and 1024, are increments of 16. As you can see, a number system based on 16 is used is the best match for digital electronic systems used in computers. Both binary and hexadecimal numbering systems will be used to express values and illustrate computer operations many times throughout the study of computer systems. Thanks for watching.